Hello again, everyone. This is Amir McKean, electrical engineer, author, publisher, and founder of AIC Publications and the Black Stemporium podcast, your number one source for science, technology, engineering, and math. How to start your own publishing business, building generational wealth, economic empowerment for our community. Today's lesson in our 10-minute engineering program is batteries, the electron pump. Now, as we stated earlier, electrons in their raw form drift in a very unorganized, chaotic way. They bounce around chaotically. Due to the difference in charges, each electron is at a different potential in charge. We talked about that last time. Because of this, greater negatively charged electrons flow to lesser negatively charged electrons. So at any given moment, there is always a mad electronic dash that exists. In order for us to utilize the electrons for our applications, we must calm them down and guide them through a pipeline toward a specific destination, which is either chassis ground or it's called earth ground. This is what people mean when they say we have to ground a generator, we have to ground an electric device. This is to prevent shock or short circuit or any other unsafe result from occurring. Keep in mind that according to our Where Does Electricity Come From tutorial, you learned last that in order for electrons to move, there must be an event that forces this reaction of movement. The battery, the electronic battery, serves as another instrument that creates such a reaction. Now, here in this tutorial, we're going to go over two types of batteries in particular. The first type is called the primary cell, and it looks like this on your screen. This primary cell is made up of two electrons or terminals that will serve as connecting posts to provide the electromotive force necessary to get the electrons into action and moving and give the electrons a resting post for them to go to as their final destination. The first post is made up of zinc, listed with an atomic number of 30. Remember, we covered the periodic table and the useful information we get from it that helps us dealing with electrical energy. Now, this atomic number of 30 that zinc has also means that there are 30 protons inside the zinc nucleus. The second post is made of copper with an atomic number of 29. Consequently, that means there are 29 protons inside of the copper nucleus. From the periodic table in the first lesson, you learned that zinc has two electrons in its outer shell and that copper has one electron in its outer shell. Because of this, the copper has an easier time freeing its electron, and the zinc will have a more difficult time letting go of its electron. When we place both the zinc and the copper in a substance designed to produce a chemical reaction, both the zinc and the copper will behave as I'm about to describe. The substance causing this chemical reaction is called electrolyte. It can be made of liquid, paste, or a solid as long as it produces a chemical reaction that gets the electrons to change the charging state. In this case, the electrolyte that's being used is sulfuric acid. Now, once the zinc comes into contact with the sulfuric acid, it reacts by maintaining and increasing its number of electrons, and it becomes negatively charged. Now, once the copper comes into contact with the sulfuric acid, it reacts by giving away its electron, thus becoming more positively charged. Thus, the copper terminal serves as the positive battery side, and the zinc terminal serves as the negative battery side. Connecting a conductor and an electrical circuit between the two terminals would cause current to flow from the negative zinc terminal post to the positive copper terminal post. And once the charge on the battery has been used up, it cannot be recharged. Now, that's the primary cell. The next battery is called the secondary cell. It works with the same principle as the primary cell with the following exceptions. The electrolyte here that's used is usually made up of a nickel cadmium mix or a nickel iron mix. Now, the zinc and the copper both react the same way when the contact is made with the electrolyte. Once again, going back to the periodic table, we see that both nickel and iron have 8 electrons in their outer shells, meaning that they won't free an electron easily, making them, meaning the nickel and the iron, insulators. Cadmium, on the other hand, has 2 electrons in its outer shell and is more easily to free an electron when compared to its nickel or its iron. Cadmium also has 48 protons in its nucleus, while nickel has 28 protons in its nucleus and iron has 26 protons in its nucleus. Now, the proton disparity between the 3 elements, along with their outer shell electron behavior, produces a reaction that not only charges the zinc as the negative terminal post and the copper as the positive post, but it allows for the recharging when the battery is discharged. That's the difference in the chemical reaction. As the battery is discharged or it's connected in a circuit, the electrolyte gets less concentrated and it begins to build up with lead sulfate. Now, the more this happens, the more inoperable the battery. Now, since lead is listed as a semiconductor on the periodic table with 82 protons in its nucleus, this also eases the recharging process of the battery. Now, as long as the recharging process connects the positively discharged terminal with a greater positively charged voltage and the negatively discharged terminal with a greater negatively charged voltage, the battery will be successfully recharged fully. If this connection is reversed, then the battery could be destroyed. That's why it is so important that when you're ever charging a battery in your car or for whatever reason, make sure that you charge the positive to the positive, the negative to the negative. I've actually seen batteries explode because people have not done this correctly. Now, once the batteries are connected into a circuit, the electrons go from being in a static or a rested potential state to being in motion. Therefore, we in engineering, we say they go from an electrostatic force to an electromotive force. They go from potential state to kinetic state. They go from rest to motion. Similar to a locomotive engine that carries its passengers on a path from beginning to end. Now, if you've enjoyed our content and you want more of it, I need you to do 3 things to help us reach more of our audience. First, go to our website using the link you see on your screen and subscribe to the AIC Publications newsletter. You do this, you'll get weekly emails whenever we release tutorials, podcast episodes, new books, contest giveaways, review copies of our books, and more. If you do this, you'll also be able to get a free book. This is very important because we want to be independent of the different platform that you might be seeing us on now. If this platform that you're seeing us on decides one day to change what they're doing, we need a way to be able to reach out to you directly, and it helps us become and maintain our independence. Secondly, subscribe to the current platform that you're watching us on now. That way you'll be alerted and it helps us grow our audience. Third, need you to share our content with at least 3 of your friends using the hashtag AIC Publications and link to our website. Thank you in advance for helping us demystify the math, simplify the science. We want all of our community members to attain the knowledge, innovate for success, and command your future. Till next time, we wish you nothing but the best. Peace.